Let us discuss three concepts in this video. Distance of a point from a set, second distance between two sets, and the last one is diameter of a set. So suppose XD be a matrix space. I have taken A and B be any two arbitrary subsets of capital X and small x belongs to capital X be any point. See, first definition is of distance of point from a set. That means suppose this is a set A and there is some point, okay, and we have to find distance of that point from set A. This is nothing but infimum, okay, infimum of distance between X and A where A belongs to capital A. That means you can take any point from A. Here you can take some one point of capital A, you can find a distance. You can take any point here, you can find a distance. Whatever the infimum minimum distance, that will be the distance of point from set A. Okay, so here you can easily see, if you select point here of this capital A, then this distance will be minimum or infimum. So this is the distance of point from a set. Okay, after that, distance between two sets. So that means suppose we have two sets like this. Suppose this is set A and this is set B. So we have to find the distance between them. So definition says again, we take one point from capital A, getting, we take one point from capital B, we find the distance between them. You can take any arbitrary point of A, you can take any arbitrary point of B, and we have to find distance between them. Whatever the infimum distance, minimum distance, that will be the distance between these two sets. That means if you select point of A here and if you select point of B here, then the distance between them will be minimum or infimum. Then that will be the required distance of these two sets. Getting? Last one is diameter of a set. Suppose this is a set A and we have to find its diameter. Diameter means supremum. Okay, you can take any 2 points of A and whatever the longest distance between them, that will be the diameter of a set. That means if you select X here, if you select Y here, then that will not be a maximum distance. But if you select point at this end and if you select point at that end, then the distance between these 2 points will be supremum, or you can say maximum. So that will be the diameter of a given set A. Okay, so you can make a screenshot of it. After that, we will discuss one example. Let us discuss this example. So in this example, they are asking a matrix space XD where it has two sets A and B. Interior set of interior points of A and B is empty set phi. But if you take interior set of interior points of union, then that is nothing but entire matrix space X. So such examples we have to find here. Okay, so I am going to consider a matrix space R with a usual matrix D. Consider a matrix space R du. Du means D is a usual matrix, okay, and I am selecting, let A is equal to Q set of rational numbers and B is equal to R minus Q, that means set of irrational numbers. So I am going to prove that see, in a matrix space R with usual matrix, this choice of A and B will satisfy this condition. So let us try to find set of interior points of A. Let I am selecting one point, X belongs to R. See, I am selecting one point from set R. For any R greater than 0, okay, I am selecting any radius, then BXR, I am interested to know open ball with center X and radius R. So you know that on the real line, if you select any point X and if you select any radius R, then open ball with center X radius R is nothing but an open interval X minus R to X plus R. So this is also an open interval X minus R to X plus R. But we know that if you select any open interval in R, definitely it contains infinitely many rationals and as well as irrational numbers. So I will mention here, it contains infinitely many rationals and irrational numbers. Rational and irrational numbers. Okay, so that means what I want to say, I simply want to say bxr is not a subset of a. A means rational number. Okay, so that means if you select any point, if you select any radius, then definitely that open ball contains infinitely many irrational numbers. So it cannot be totally containing a. That means set of rational numbers. Sorry, it's not containing a, and a is equal to q. So therefore x does not belongs to q interior. That means if you select any point, 100% it is not an interior point of q. If q has no interior point, then set of interior point is phi. So therefore a interior, that means q interior, is equal to phi. So in this way we proved a interior is equal to phi. Similarly, we can prove that B interior is also equal to phi. B interior means interior points of set of irrational numbers. Same logic. Okay, the logic we have used for rational, same logic we can use for irrationals also, and we can prove that it is also equal to phi. So see, these two conditions are satisfied. Let us try to check the last condition. Now A union B, that means rationals union irrationals. So if you take union of rational and irrational, definitely it is R, set of real line, entire set of real line. So therefore A union B interior is equal to R interior, which is equal to R itself. Since R is an entire matrix space, so it is an open set. So therefore their set of interior points is R only. So that means last condition is also satisfied. So that means set of real numbers with usual distance. A is equal to rational number, set of rational numbers, and B is equal to set of irrational numbers satisfy this condition. Okay. So yeah, example is over. Make a screenshot of it. After that we will stop. Thank you. Bye bye.